Continuing on in section 4.6, we have a take note here for completing the square. It's on page 235 in your book. So our steps for completing this, solving an equation by completing the square, the first thing we're going to do is we're going to get it into our form here, x squared plus b to the x. So sometimes we're going to have to subtract or add to get our c on the other side. And if we have a coefficient other than x, we have to divide every term in the equation by that coefficient. Again, we want it to be x squared plus bx plus c. Then we're going to complete the square by adding b divided by 2 squared to both sides of the equation. We'll factor it into the binomial square. We get rid of our square by taking square roots, and then we solve for x. And I'm not going to play this YouTube video on my YouTube, but if you search quadratic payphone, that will be Mr. Boardman that I showed in class. That will be the video there where he walks through the steps as well. So he takes our standard form quadratic, ax squared plus bx plus c equals 0, and solves it by completing the square, and it actually gives us our quadratic formula that we'll worry about next section. But the steps are all there as well, and sometimes it's a little bit easier to remember the steps in like the song format. So either way, but I would encourage you to check out that video as well. In example 5, we're going to solve by completing the square here. So again, our first step is to rewrite the equation so that it's x squared plus bx equals our constant if there is one. So I'm going to subtract a 6 so that I just have my x squared and my x term on the same side. Now I also just want an x squared. I don't want any coefficient other than 1, so I have to divide by 3. And when I do that to every term. Now we complete the square. Step 2, complete the square. We take our b term, half it, then square it. And we add that to both sides. Whatever I do to one side, I have to do to both. Now, this is a perfect square trinomial. X times x, 2 times 2, multiply together and double gives me 4. So x, I take my sign, minus, and that half of b here, 2 squared. My perfect square trinomial is always going to be x half of b squared. It's like I just put an x right in here in that parenthesis. Okay, and if you're not sure, you can factor that down the way that we've been doing it before. And now we're just going to solve. I get rid of a square by taking a square root. Whatever I do to one side, I do to both. Don't forget when we take the square root, it's plus or minus. And then add or subtract. So here I get x equals 2 plus or minus the square root of 2 as my solution. Now feel free to pause here and give this a try if you'd like. Again, I'm going to get set equal to 0 first. And you wouldn't have to. You could get it in that x squared plus bx form. But this is going to give us the same starting point. So again, I have it in standard form here. Our goal is to get it to be x squared plus b to the x. So I'm going to add 6. And again, we could have just subtracted a 3 here and moved that to the other side. Instead of moving everything set equal to 0, doesn't matter. So I have my x squared plus b to the x equals c. But my problem here is that I want just one x squared. And I have 2. So now I need to get rid of my 2 by dividing. And we do that to every term. X squared minus x equals 3. Matches my format. Now I complete the square. I take my b value here, which is -1, half it, square it, and add it to both sides. That allows me to write my perfect square trinomial that I just created over here as a binomial squared. X, take my sign, and half of my b term every time, or half times half is what gets me to a fourth. Again, it's like I just put an x in with my parentheses there. Here, common denominator is 4, so I get 12 over 4 plus 1 over 4 gives me 13 over 4. To get rid of my square, I'm going to take the square root of both sides. Square root here of 13 is just 13, square root of 13, but the square root of 4 gives me 2. So the square root of 13 is going to stay the square root of 13, but I can actually take the square root of 4 and just get 2. Now I'm going to add a half to get my x by itself, and I get 1/2 plus or minus the square root of 13 over 2. We can also write this here if we wanted to as 1 plus or minus the square root of 13 all over 2, since we have a common denominator there. And this is going to look more familiar when we get into section 4.7. So again, our first goal is to get it into x squared plus b to the x equals constant. Then we'll complete the square by taking our b divided by 2 squared and adding that to both sides. We write it in factored form as our binomial squared, and then solve. We take the square root to get rid of the square, and then add or subtract. And again, if you search on YouTube, quadratic payphone, there's another video where he walks through the steps in a catchier tune that might help as well. So if you're still not 100% sure, check out that video. In example 6, we're writing in vertex form. So here we start off with the standard form quadratic, and we want to put it into vertex form. And we did this in section 4.2 using the negative b over 2a, but now we're going to do it by completing the square. So the first thing I'm going to do is still try and get it to be x squared plus b to the x. Okay, so I'm going to take and add that 6 to the other side. Right now I have y plus 6. You don't have to worry about this y right now. It's technically there, but we don't have to worry about it. We're not dealing with it at all. We're just dealing with our x's and our constants. So now that I have my x squared plus b to the x, just like I wanted it to be to complete the square, I take my b, half it, square it, which gives me 2 squared, which is 4. I take that value and I add it to both sides. So I get y plus 10 equals x squared plus 4x plus 4. Now, my x squared plus 4x plus 4 is a perfect square trinomial. So I can rewrite this in factored form, x plus 2 squared. Again, it's always like I just put x, and here I had a positive 2, so plus 2 squared. Or x times x gives me x squared, 2 times 2 gives me 4, 2 times x doubled is 4x. Now the only difference here is instead of solving this for x, we're putting it in vertex form, which remember is y equals a times x minus h squared plus k. So I'm still going to set it equal to y by subtracting a 10. So because we're looking for vertex form, here I have vertex form. Y equals x minus h squared plus k. Now it says name the vertex and our y-intercept. Our vertex, remember, vertex form here is going to be h, k. So here I have x minus negative 2 squared is how I get to that plus. So my h is negative 2, my k is negative 10. And my y-intercept is anytime x is 0. So it's always going to be my c value in standard form, or the point x is 0, y is negative 6. And we can find that in vertex form or standard form. If I plug a 0 in for x here, I get 4 minus 10, which is negative 6 as well. But it's always going to be our c value. So just keep in mind what a y-intercept means. Our y-intercept is where it crosses our y-axis, and that always happens when x is 0. So here we have our vertex form. Again, we got it in x squared plus b to the x form. by subtracting or adding that c value to the other side. We took our b value, halved it and squared it, added it to both sides. Wrote my perfect square trinomial as a binomial squared, and then got it set equal to y again. Now, feel free to pause here and give this a try if you'd like. We're going to write this equation here, this function, in standard form. In vertex form. We're going to go from standard to vertex form, and then name our vertex and our y-intercept. So our first step is we're going to try and get it to be x squared plus b to the x on one side. So in order to do that, I add the 6, move that constant over. And now I have it in the form I want. Once I've got it in the right format, I can take my b value here, half it, and square it. Add it to both sides. Same as 2.25 here, guys. I'm going to simplify here. On my left side, my common denominator is a 4. If I change the denominator, I change the numerator. And I get 24 over 4 plus 9 over 4, which gives me 33 over 4. Here, this is a perfect square trinomial. X plus 3/2 squared. Again, it's always going to be half of our b term. Otherwise, to get to 9/4, we take 3/2 times 3/2. And one of those factors goes in here along with the sign for the middle. Now again, we're looking for vertex form. So to get it set equal to y, I subtract that constant back over. And I get y equals x plus 3 over 2 squared minus 33 over 4. Now, my vertex is h. Remember, this is x minus negative 3/2. K. And my y-intercept is my original c value, which again is the 0.0, -6, because our y-intercept always happens when x is 0. So again, be aware what the question's asking. Here it's asking for it in vertex form. So we want y equals a times x minus h squared plus k. We don't want to actually solve it here. We're just getting it in that vertex form. And we can do that by completing the square. And again, we also did that in section 4.2, I believe it was, by finding our axis of symmetry first and then plugging it back in. So either way, we can get to where we need to be here. Quick recap here. Completing a perfect square trinomial allows the completed trinomial to be factored as the square of a binomial. An equation that contains a perfect square can be solved by finding square roots. The simplest of this type of equation has the form a times x squared equals c. And the real solutions of a quadratic equation show the zeros of the related quadratic function and the x-intercepts of its graph. And that's all I have for section 4.6.